This is my first video lesson for Unit 11, Solutions. In this lesson, we'll be describing a solution. Go to page 2 in the class packet. You can download the class packet on my website. Motivation. Take a moment to think about the process of making Kool-Aid and what is the opposite of dissolving. We will discuss this later on in the lesson. Learning target. At the end of the lesson, I'll be able to describe components of a solution and describe what factors affect solubility. One will be number 1, which will be a junipod based off this lesson. This is review from Unit 1. A solution is also known as homogeneous mixture. It is uniform in composition, which means the particles are evenly distributed. It cannot be filtered and does not scatter light. So there's two parts to a solution, the solute and the solvent. So from the motivation, how do we make the Kool-Aid? The powder is the solute and it's dissolved in water, which is a solvent. That is how you make the Kool-Aid solution. So the Kool-Aid powder is the solute, is a substance that gets dissolved. It's the minority component of a solution. The solvent, on the other hand, does the dissolving. That's the water in this case, and it's the majority component of a solution. A common example of a solvent is water. Learning check number 1. A solution is formed by dissolving 50 grams of NH4Cl in 100 grams of water at 50 degrees Celsius. Which statement correctly describes the solution? Pause the video and resume as completed. In this scenario, NH4Cl is the solute because it's being dissolved by the solvent, which is water. So the answer is choice 1. When a solute is added to a solution, there are two possible scenarios. Either the solute is dissolved in the solution, as indicated from this GIF and from this equation, or crystallization occurs. Crystallization is when a solid crystal forms or precipitates from a liquid solution. Here's a GIF showing crystallization. The opposite of dissolving is precipitation and crystallization. Here's a summary slide. There's two parts to a solution, the solvent and the solute. The solvent does the dissolving. Example of that would be water. The solute is being dissolved. An example of that would be salt. A solution is a homogeneous mixture. An example of that would be salt and water. Here's a GIF of a solute dissolving in a solvent, forming a solution. Solubility is defined as the ability of a solute to dissolve in a solvent. This is considered a physical property. Solubility of a solute can be either soluble, in which most of the solute is dissolved, or insoluble, which means very little of the solute is dissolved. So solubility is determined by these factors. Polarity, the charge distribution in a molecule. SNAP, symmetrical nonpolar, asymmetrical polar. Intramolecular forces, and here are some examples of those, and entropy changes. So solubility can be altered or changed by the temperature, in the case of solid and gases, or pressure, only gases. Just to review from Unit 5, polarity is the distribution of charge in a molecule. If the distribution is symmetrical, the molecule is nonpolar, as seen here. If the distribution is asymmetrical, the molecule will be polar, as you can see from this water molecule. Here's a guideline from last term. Like dissolves like. Typically, a nonpolar solute will dissolve in a nonpolar solvent, but not in a polar solvent. A polar solute would typically not dissolve in a nonpolar solvent, but will dissolve in a polar solvent. Ionic compounds, similar to polar compounds, would typically not dissolve in nonpolar solvents, but will dissolve in polar solvents. Check of understanding number 1, determine if the solute given is soluble in the solvent. Let's look at the first example. Here we have water, which is a polar solvent, and KBr, which is an ionic compound. Ionic compounds typically dissolve in polar solvents, so this will be soluble. In addition, whenever you see an ionic compound and the solvent is water, check table F on your reference table if it's soluble or insoluble. Take a moment to do 2 to 6 on your own, pause the video, and resume as completed. Here are the answers. If we look at question 4, AgCl, which is an ionic compound, is insoluble in water if you look in table F. Check of understanding number 2. Determine the solute and the solvent based on the description given. Pause the video and resume as completed. Here are the answers. Question 1. Soda is a carbonate drink. What does carbonate mean? It means a dissolved gas, in this case, carbon dioxide. Question 2. Why a bottle of soda goes flat when you forgot to put it back in the fridge or leave the cap off? So here's an example of soda fizzing, and over time, the fizzing stops. This is because the dissolved gas, the carbon dioxide, escapes. Now we're going to talk about the factors that affect solubility. Here are the main ones: the properties of the solvent and the solute, temperature, pressure. Here are the minor factors: concentration, surface area, and stirring. So for the rest of the lesson, we're going to focus on temperature and pressure. Let's start on how temperature and heat affect the solubility of most solids. So how might increasing heat and temperature affect the solubility? As temperature increases, solubility of most solids will increase. So why is that? Here we have a solid solute added to a solvent. The solid solute is initially held by intramolecular forces. That is what's holding the atoms in the solid together. Therefore, in order to break these intramolecular forces, energy must be applied. Therefore, as temperature increases, solubility of most solids will increase. So breaking exort releases forms. Increased energy is used to break the intramolecular forces in the solid, therefore increasing solubility of the solid. Now let's talk about the solubility of gas and its relationship with temperature. In this example, we have oxygen gas, which is the solute, dissolved in water, which is the solvent. What type of intramolecular forces are present? Between the oxygen gas and water, there are dispersion forces only. How might increasing the heat and temperature affect the solubility of the gas? As the temperature increases, solubility of gases will decreases. So why is that? When you increase the temperature, the molecules will move faster and break those intramolecular forces. As a result, the gas molecules will escape. So breaking exort releases forms. Increased energy is used to break the intramolecular forces between the gas and solvent. The gas molecules will move faster and leave the solution as a result. Is a similar reason between vapor pressure and temperature from last term. Here are the graphs for solubility versus temperature. For a gas, it is an indirect relationship. For most solids, it is a direct relationship. As temperature increases, the solubility of a gas will decrease and the solubility of a solid will increase. Next, we're going to look at how pressure affects solubility. Using the diagrams, how does pressure affect gas solubility? If you compare the two diagrams, we're increasing pressure. Notice that we have more gas molecules dissolved in solution. Therefore, when you increase pressure, you're going to push the gas molecules into the solution. Therefore, the solubility will increase. So here's a graph of solubility versus pressure for a gas. As the pressure increases, solubility of the gas will also increase. How about a solid? How does pressure affect the solubility of a solid? Let's look at the diagram. When we increase the pressure, notice there's no change in the solubility of a solid. Therefore, pressure has no effect on the solubility of a solid. So this is what the graph will look like for a solid for solubility versus pressure. It will be a flat line because pressure has no effect on the solubility of a solid. So how can we prevent soda from going flat? Basically keeping the carbon dioxide in solution. Based on what we just learned, you can decrease the temperature and increase the pressure. In summary, for solubility of gas, gases are most soluble at high pressure and low temperature. You have to notice for the Regents exam. Learning check number 2. Under which conditions of temperature and pressure is a gas most soluble in water? Pause the video and resume once completed. So the answer is choice 4, low temperature and high pressure. So this concludes the video lesson. Remember to do the Junipod homework.